Welcome back to the channel. Last and final video. Let's get into it. How to determine the
and behavior of a rational function by
Dan
and Matthew.
Let's get into it. So right now we're going to explain some key vocabulary words that you need to know for this lesson.
Alright, so some vocabulary words we'll be using throughout the video. I know there's a lot, but all of these are important. You got to make sure you know what they mean, so it'll be easier to understand your work. So first we'll start off with the rational function, which is a function written as a fraction with polynomials on top and the bottom.
And then we have a numerator, which is the top part of the fraction.
The denominator is the bottom part of the fraction.
The degree is the biggest power of x in the polynomial.
And the leading term with the highest power of x. The leading coefficient is the number in front of the leading term. The end behavior is what the graph does on the far left and the far right.
Okay, so for the positive infinity, it's basically just what happens when the x gets really big. And for the negative infinity, it's really what happens when the
x gets really negative.
And then the horizontal
asymptote
is a line that the graph gets close to but doesn't cross the ends of the graph. Okay, now it's question number uno. So now for problem uno. That's a very simple equation to kind of get the student, more understanding. So we have f parentheses x equals 2x plus 1 equals x. For right now, we have to step by step identify what kind of function this is. We could obviously tell that this is a
rational function.
Rational function because it has polynomials on the top and bottom.
It is a fraction with polynomials. So yeah.
Correct. Now we have to look at the degrees. So we have 2x plus higher 1, and we have x right here, which also has the same type of degrees, which is 1. So when the degrees are the same and the end behavior, it only mainly depends on the leading coefficient. So the leading coefficient would be this right here, 2x, and the leading term in the denominator is x. So we have to divide these. So it would be 2x divided by x. X equals 2. So our end behaviors are 2, right? So it would be, sorry for this, our end behaviors would be a as positive.
Ax goes into infinity.
Goes into infinity, negative infinity. This would be positive, comma, f into 2. So our final horizontal
asymptote
would be y equals 2. Sorry, but y equals 2, and yeah, pretty easy to understand. Okay, coming at it back is strong. Nice problem 2. It's still somewhat easier, but it gets a little gradually difficult. So we have f parentheses x 3 over x. So we have to identify the degrees. In this case, it's just the 3 and x, something simple. And these end up having a degree of 0. So the denominator of x, which is b uno. So we have to compare the degrees, and
the numerator's degree is less than the denominator's degree, as you can see right here.
Yeah, as you can see right there. So now we have to
apply the rule. So when the denominator has a higher degree, the fraction gets closer and closer to the 0 as x gets very large or very small.
So overall end behavior would be a s infinity negative infinity, parentheses, f, parentheses, x, parentheses, equals 0. So our the horizontal
asymptote is just y equals 0.
this one pretty simple. The next one is a much harder question, so let's get to it.
Put that too. Okay. Okay. 3, 2, 1, go. All right. For the third problem, we do have a little bit of a hard question, but that's just to help you guys be more comfortable while answering these type of questions. While probably know what the numerators are and the denominators, you know, and on this type of subject. Okay. So we're gonna start off. The equation is just f to the x equals, give me 1 second. 4x to the third. Then it'd be negative x plus 6. It's gonna be a fraction over 2x to the square plus 5. So as you can see, for this we need to identify the degrees of each polynomial, and doing that we find these. That's the numerator and this is the denominator, since on top that's north. And keynote, you always gotta make sure and find out which one's higher than the other. So as you can see, the 3 is higher here and this is lower. So when the numerator is greater than the denominator, they agree. When this happens, there is no horizontal asymptote, and the end behavior follows a slant asymptote, meaning the function increases or decreases without leveling off. To understand this, the direction, I compare the leading terms. So let me just write down 4x to third 2x squared, which would equal just 2x. And for the end behavior, as x goes into positive infinity, fx goes into, positive infinity also over here. Okay, and for the bottom, it would be as x, sorry, I wrote that backwards, as x goes into negative infinity, f of x goes into negative infinity. Okay, so with all this, the function does not approach a constant value, so there's no horizontal asymptote.
So there's no final question or final answer?
No.
Okay, so this is like there's no real solution, right? Basically.
I guess you can say that in a way, because there is no horizontal, so there's really pretty much it, yeah.
All right, then now question number 4. Let's get to it.
For the last question of this lesson, it will be about a railroad story or application. So the story goes, a company tracks the efficiency of a machine over time. The efficiency score is modeled by the rational function. So we'll be writing down what it is, our equation. E to the t equals 6t squared plus 10, this fraction again, over 3, 2 plus 2t, sorry, let me make that a little bigger, my bad, and 8, okay? Sorry, can't really see that well. 2t plus 8, okay, that's it. So the t represents the time in months, and the company wants to know what happens to the efficiency after a long time. So I'm going to identify the leading terms of the numerator and the denominator. The numerator would be 6t, and the denominator is going to be 3t to the square. Sorry. Okay, and I compare the degrees, which are both 2, as you can see. Since the degrees are equal, I divided the leading coefficients, and I'll show you how we do that. It's gonna be 6t over 3 squared, for I say that for last, equal 2. And the end behavior will just go very short as t goes into positive infinity. I'll write in a second. E goes into t to 2, and as t goes into negative infinity, e of t goes into negative, just 2. So even though the negative time isn't realistic, it still applies mathematically. So the horizontal asymptote is e of t equals 2. And that's the whole question for the real world situation. I'm trying to figure out.
This situation is very important for the real world because it helps determine like, you know, for example, businesses like if the machine costs a high amount of money but it doesn't last a lot of time,
they want to kind of track the efficiency of how it does in like a long time
in order to like track profits and then like see how much revenue they get. So yeah, this is something that's pretty useful. And as a end note, that's the end. That's our final video. You know, Ms. Ramirez, if you're watching this, we poured our heart, our blood, our sweat to this assignment.
We put 7 hours into this work.
No, like more. We started at 5. It's currently 2 a.m.
Okay, it's 2 a.m. My bad.
You know.
Sorry if like the recording's bad. We're really like tired, but like this is our help, right? Put our sweat and tears into this once again. And thank you for watching.
Peace. Bye.